A very good afternoon to the participants at India and to Professor Bamberger there abroad. Today we are here for a panel discussion on CAETS Energy Report 2022. The topic of the discussion is towards low GHG emissions from energy used in selected sectors. So very briefly, today's program we have panned out in such a manner that initially we have a welcome note by Dr. Mathur, followed by a welcome address by Professor Manna. Then there'll be a presentation by Dr. Bamberger, Vice President, French Academy of Engineering and Chairman of Energy Committee of CAETS, followed by a brief supplementary presentation on buildings by Dr. Bibek Bandyopadhyay, FNAE. Then there will be a discussion on the topic moderated by Dr. Mathur, followed by concluding remarks by Mr. Pradeep Chaturvedi. So without going further, I will invite Dr. Mathur for his welcome note to the members here. But before I do that, let me briefly introduce Dr. Mathur to you. Of course, he's a well-known figure. Everybody knows him. Dr. Mathur, FNAE, is Director General of International Solar Alliance, a 114 countries organization dedicated to making solar as the energy choice in its member countries. He was earlier the Director General of the Energy and Research Institute, which is called as TERI, for a period of 5 years. And he was also the same of the Bureau of Energy Efficiency from 2006 to 2016. Over to you, sir, to take over this session.
Thank you. Thank you very much, Colonel Rai. May I say what a pleasure it is to welcome all of you to this seminar. I'm particularly delighted that Professor Manna and Professor Bamberger have joined us as well. It was a matter of great pride for us when CAETS asked Professor Bamberger to prepare this special report on the engineering challenges to decarbonize the hard to abate, or let me say harder to abate sectors. And Yves, I can discuss this in great length on why we call it harder, but that's a separate story. Like this report, like the organization I work with, the International Solar Alliance, is an Indo-French collaboration. We were delighted that it builds on the renewables report and the urban infrastructure report that was done by the Academy, by the Indian National Academy of Engineering, and fed into the work that was prepared, that went into the preparation of this report by Professor Bamberger. I'm not going to spend a lot of time in introducing the subject. All of us know that we are incredibly and indelibly deep into the climate change crisis, whether it is the climate patterns or whether it is the impact on humans. We have started seeing impacts on human health in India, particularly increasing heat strokes because of the greater incidence of temperatures that we are seeing. This also implies that we need to obviously modify our electricity system, and the organization I'm with, the International Solar Alliance, works towards promoting solar in all developing countries and the developed countries where it makes sense. But at the same time, we also need to look at what do we do in areas which we cannot electrify. We are looking at electrifying urban transport, but what about industry? What about the building sector? These are areas which have traditionally proven much harder to change, much harder to decarbonize than, say, the electricity sector. It was with that in mind that all the academies of engineering of the world came together, and CAETS and its energy committee under the leadership of Professor Bamberger started work on looking at what are the key challenges, the engineering challenges in the decarbonization of the harder to abate sectors. I must say that I have shamelessly copied from this report and believe, first of all, I request everybody to go through this report. I think it's a wonderful piece of work, and I think it helps us focus our thinking, whether it is in influencing the work of our peers, the students who work with us, or it is in influencing the work through the Department of Science and Technology or the other ministries who we work with. This, to me, is the challenge of the hour, to create the demand for cleaner energy sources so that the harder to abate sectors also become abated sectors in a few years. Maybe I'm being a little too optimistic, but I do hope that this will happen sooner rather than later. I will request our president, the president of the Indian National Academy of Engineering, Professor Indranil Manna, to say a few words. Professor Manna is, of course, our president and the Vice-Chancellor of the Birla Institute of Technology in Mesra. You all know that he has been director of IIT Kanpur and of CGCRI before that. But I think his work on aluminum alloys, particularly the steel, magnesium, aluminum alloys and the laser surface strength working on that is something that is globally renowned. It is with great pleasure that I request Professor Manna to deliver the presidential address.
Thank you very much, Dr. Mathur. It was very gratifying to hear the introduction by you. I certainly am very honored. Professor Bamberger, we are extremely privileged to have you with us today. I had the privilege of listening to you presenting this report in the CAETS annual meeting in Versailles. And I know how happy the CAETS Council was with this report. Certainly a very informative and a scholarly piece of work. I was also very happy to hear that some of our colleagues from India, from our academy, Dr. Mathur, Dr. Bibek Bandyopadhyay, Mr. Pradeep Chaturvedi, they very handsomely contributed. In fact, Mr. Chaturvedi probably coordinated from the input from the Indian side. So we are very happy, and happy for one more reason, that we always maintain that Indian National Academy of Engineering is devoted to the profession and the country. So there's no two doubts that like water, food, and shelter, energy is one other very important source for sustaining life on Earth. And in India, we are already, or probably will soon be, getting a certificate of being the largest population in the world, and that too a very young population, probably the youngest population in the world. So these two attributes put together certainly makes us believe that whatever energy policy this country follows will have a very wide ramification to the entire globe, not just this very country. And the fact remains that out of about 400 gigawatt hour of electricity that we have the capacity for producing, more than 2/3 is fossil fuel. And that's a concern because, number one, it is not going to last forever. It's getting depleted very soon. And number two, because it has certain adverse effect on the environment, particularly when we use coal. Now, this is one side of the story. The other side of the story is what I commented initially, that we are a very young nation and largest population in the world, nearly 17–18% of the entire humanity. And coupled with the fact that the per capita energy consumption in this country, somewhere I read, is about 1/5 or 1/3 of the world average. So that means this young and aspiring population will look for more access to energy. And unless Dr. Mathur does well and provide a lot of solar energy, we'll be hopelessly dependent on fossil fuel, which is a matter of concern. One other fact is that though India happens to be one of the earliest nuclear energy harnessing nations, but our contribution to the overall energy bill is not even from nuclear energy, is not even 5%, is way less than that. So we have opportunities, we have scope, and the country is at the same time very big economy, third largest in terms of purchase power parity and fifth largest in terms of nominal economy, nominal GDP. And the GDP is growing at least at the rate of 6% per annum, which means there'll be a lot more industries, a lot more manufacturing activities, and so on. Fortunately, sun god is quite benign on us. We get a lot of sun rays. So in winter, we don't have to burn a lot of fuel. Still, there are regions where we do have a lot of energy need. So this is my own perception about why energy is so important to us in India, like any other place in the world. And Indian National Academy of Engineering being devoted to the profession of engineering and the well-being of the humanity, we certainly would like to hear Professor Bamberger present the key points of this very important report that was created by the energy group of CAETS. And we would also like to borrow from that and adapt, and so that the country as a whole benefits. So thank you so much, Professor Bamberger, for joining us. And to you, and I would request Professor Mathur, would you like to say a few words about Professor Bamberger, or can we then get started?
It's a delight to welcome Dr. Yves Bamberger to this seminar and to request him to present the CAETS report. He is an example of both an engineer of practice and a professor of engineering at the same time. He has been in leadership positions in Electricité de France. He was director of transmission and distribution. He was director. He was director on the board. He was a senior advisor to the chairman and CEO, and he has also been an adjunct professor at the École des Ponts et Chaussées. I hope I'm pronouncing it correctly. You know, as a graduate of Roorkee, it was a matter of great horror for me to learn that the École was actually established even before Roorkee was, but that is the reality. Before this report was written, Dr. Bamberger and his colleague, Eddie Purgell, wrote the book on electricity, humanity's low carbon future, which I strongly recommend. I mean, for me, it has been a huge revelation of the ways in which we could use carbon-free electricity in a myriad of ways which we don't even think of right now. I would also note that Professor Bamberger is a founder member of the French National Academy of Technologies, and its vice president. He's also the chairman of the CAETS Energy Committee. And without further ado, Professor Bamberger, can we request you to present the CAETS report?
Thank you, Professor Manna. Thank you, Dr. Mathur, for this so kind presentation, for inviting me. I'm really happy for two reasons. First, I'm happy that it gives us and my colleague Bibek Bandyopadhyay to present the report. And secondly, because for me it's a great honor to participate to such a webinar organized by your academy. So the title, what is the title of the seminar? Towards low-GHG emissions from energy use in selected sectors. We had to select sectors because we couldn't study all sectors, and we also thought that it's perhaps better to select sectors where we could find colleagues to work on than to try to embrace all aspects. We moved to energy use in the CAETS Energy Committee since the previous reports were far more on generation side and also on the electric system. We have two focus. The first is to insist on the fact that there are already available and affordable technologies. It's clear that we need R&D to continue to improve the performance of technologies and also to develop new, to innovate and so on. But there is no excuse, there are no excuses to wait for these new technologies. In all sectors are already technologies ready for deployment. That is the first message of our report, and we will show it through the examples and case studies and development which are in all chapters. Secondly, we allowed us to think that some of our comments and messages and recommendations could be useful, as written here, for policymakers who have a very complicated and complex role to decide to try to arbitrate between lobbies, between short-term, long-term, and so on. So we choose, you have here the structure of the report, and at the same time the list of the 7 sectors on which we have worked. The first chapter, I will develop it a bit later to set the scene, to give some general transverse comment. And then you have the list of the 7 sectors. For each sector, I organized with the colleagues a working group, and these working groups were always chaired by 2 colleagues from 2 different continents. I thought it would lead to a more richer text. And so you see here that Dr. Pradeep Chaturvedi was was one of the co-chairs for the buildings and smart cities. And you see here the colleagues from different countries. We had 69 authors from 20 countries. All that has been made during the outbreak, during the pandemic. And the annexes, which will be soon on the CAETS site, are containing information from all countries and sectors, and they will arrive only in a few weeks from now, because we wanted to verify, to check all the copyrights for the figures. What you will find in the chapters, all the emissions from all these sectors together, as written on these slides, are more than 40% of the GHG emissions. Why only 40? But 40 is a significant part, since we didn't study, as you have seen, transportation. It will be the next report from CAETS Energy Committee this year. And we didn't study generation sites. So it explains, it's the reason why we were, I would say, concerning only, but still 40%. In the chapter 0, we describe the role of electricity, of low carbon electricity, renewables and nuclear, explaining that for us in the report, the idea is when you are trying to reduce the GHG emissions, the principal low carbon source could be the direct use from the solar, but it's not so easy to use solar for solar heating, for radiative cooling. Probably Bibek will come back to this subject later. You could also try to dry some fruits or some food outside, but globally direct use of solar is relatively limited. So it means that you have to use low carbon electricity and try to have enough low carbon electricity, which is the key point, especially probably for the next decade. And in some cases, it's not possible to use directly electricity. We will see some in a few minutes from now. And in that case, for example, low carbon hydrogen, it means hydrogen produced in most of the cases through renewables or through electrolysis, for nuclear through electrolysis, could be a solution. In this chapter, we give first some technical comments, and then some more, I would say, political, or not political, but organizational comments, because we are academies. We thought we don't have to go to do politics, but we try to help the leaders. So the first bullet point is on what I've already said. Low carbon technologies are available. And that's an interesting point. They have often co-benefits. For example, if you replace biomass cookers, which are very bad often, especially in some countries of Africa, when you electrify that, you have co-benefits for concerning pollution emissions and some dangers NOx and so on who could come from that. So low carbon technology, we had a discussion on energy efficiency, and energy efficiency, we all know, especially in buildings, that there are some rebound effects which are limiting the effect in some cases of energy efficiency. We know also that, for example, insulation of buildings may be in some cases more expensive to do to reduce CO2 emissions than to change the heating system, for example. But probably we will come to that later. We also recommend that the synergies between users, for example, a DP center could heat some offices nearby, but at the same time, when you are using synergies without enough, when you are not careful enough, you could have some problems, resiliency problems if one of the use is out. Then we were insisting on the importance of matrix. Importance of matrix we see in some policies that when you change the metric, you change the policy. I will give an example a few minutes from now. And then in this chapter, we were insisting on three, I would say, one technology, one product, and one method, which are very important for the GHG emission reduction. The first is heat pumps. Even if they are more known now, when we look on the newspapers, on the internet, or the conversation, everyday conversation, I would say, between engineers and more people are more on electric cars or on nuclear, or some cases also on hydrogen, not so much, not so often on heat pumps. Heat pumps is clearly a key technologies to decarbonize in buildings, in industry, in the offices. And so it's a magic technology, since a heat pump is doing the reverse of what damn nature is doing, since it's bringing, is keeping heat where it's cold to bring it when it's warm. That's exactly the contrary of what damn nature is doing. And the type of heat pumps there are more and more types of heat pumps with more and more efficiency, with a scope, a coefficient of performance, which are better and better, and with less impact on climate change, since the coolant of heat pumps are better and better. Hydrogen, I won't develop that now, we don't have time, but we are thinking here to low carbon hydrogen produced by renewables or by nuclear. And life cycle analysis, there are different ways to do that. We think it's in the discussions that we have in the different working groups, the people who are my colleagues, our colleagues who are insisting on the interest of using more life cycle analysis to see the consequence of what we are doing, or to see the consequence of a change in the industrial process, for example. So these are more technological aspects. If I move to this right column here, it's far more to insist on some other aspects. The importance of holistic aspects or holistic views. That way it could be very banal, but what we have seen in different countries, and not only in France, is that often we see policies or choices which are done without looking on all the external consequences in the system. And so we think that we have to help our policymakers, administrations, industrial leaders to have more global, more holistic approach. The second thing, but we were colleagues from the different academies coming from industry, from the academic world, and so on and so on. We are knowing perfectly that to deploy all that, there are real difficulties, contradictory interests, and so on. We are not naive. We know that it's difficult. The third point on which probably the policymakers could pay more attention to that is to make regulations and which are more stable and more predictable. That they say we do that for the for 3-4 years, where announce where the change will be decided, in which direction, and so. That's not so difficult to do in many cases, but it's not often done. Benchmarking, we have some examples which are in the report on the interest of doing benchmarking. For example, our Japanese colleagues or our colleagues from Italy are doing benchmarking, are pushing industrial sectors, are doing benchmarking between the different companies of the sector and trying to push the emissions reduction in a sector, helping them and so on and so on, and helping them to benchmarking. But it's described in the report. Then in all sectors, we have seen, but I'm sure you are knowing that in your academy in INAE, skills and competencies are everywhere for all sectors will change. All competencies some we will need less, some we will need more. Anyway, they will have to change to be renewed, and we need also new competencies. That's the case everywhere. Also for very old sectors like building or like agriculture. Then, but it's evident, we need effective leadership and arbitration capacity, which is not so easy. So I give short examples on buildings, but I will be very brief because I know that Bibek Bandyopadhyay will describe buildings and cities far more. It was only to mention the very simple point. Are you pushing energy efficiency or are you pushing low carbon? That is not exactly the same. And here you have an example. The example is in the report when we are discussing the importance of the matrix. It's clear that that's the example here. When you are insulating, you reduce the emissions, but with less insulation and moving to electric heat pumps, you are reducing the CO2 emissions far more in many countries. I gave here a Spain electricity mix. In France, it would be, I would say, better because our CO2 content of electricity in France is very low. But even if you have 400 grams of CO2 per kilowatt hour, it will be always better to move from gas boiler to electric pump heating or cooling. But I don't want to go further on generalities. What you will find in the chapters is not, the chapters are not a complete monography on each sector. That was not our goal. It's also not possible because the situation is very different from one country to another. But what we've tried to do is to always to give the order of magnitude of the emissions of the sector at the world level, then describe the principal technologies for decarbonization, giving some ideas on the public policies, eventually in different countries, and some narratives. And always we have seen that education and training is coming, as I was mentioning, and we have case studies in all chapters from different countries, depending on the composition of the different subgroups. So I don't have time and don't want to bore you going through all chapter, and I will give, perhaps I have time to mention 3 chapters briefly, knowing that Bibek will speak deeper on the chapter on buildings. So our first chapter is on food and agriculture. We know that in this sector, it's essentially principally methane, which is produced, which is the gas for GHG emissions. There are very different variables, variable definitions of this sector, and even if we don't change the agriculture practice, that it's the products, even if with the existing agriculture, there are many possibilities for methane reduction. They are mentioning in the report, not only with new feed additives, but also modifying slightly the rice cultivation, improvement in irrigation. That's a very key point everywhere. And also, there are many possibilities on electrification, not only in agrivoltaic. I'm sure that Dr. Mathur would be happy to say that we have sought to agrivoltaic. And also that there are many new technologies concerning also the way to develop plant. We have examples on advanced greenhouses and vertical farms. That it's, you will find many ideas, I think, in this chapter. The chapter of buildings, I don't go. I want to mention this chapter, oil and gas. When we are discussing here oil and gas, it's Scope 1, Scope 2. It means we are thinking to the emissions before combustion, before the end use that we are doing in our cars, in our plants, in our building to heat and so on. It's emissions produced by the industry of oil and gas. And what is perhaps not well known is that almost 1/4, 24% of the total emissions from oil and gas produced by the mankind are coming from the industry, from oil and gas industry itself. It means that 8% of the total GHG emissions in the world are done by the industry of oil and gas itself. We know that the refineries and all the plants from oil and gas industry are optimized, that's clear. But they are producing methane by flaring. There are many fugitive emissions of methane. The heating is done using oil and gas and not electricity. And so in the chapter, the colleagues who were working on the chapter, and all that was discussed after when we were all together, it's clear that there are possibilities which are not so costly and in some cases could bring money to reduce relatively rapidly the methane emissions. When we were discussing that, it was not in the newspapers, it was appearing these last trimesters more, but there are many possibilities to reduce the emissions of oil and gas industry before combustion, before we are putting gasoline in our cars or buying gas for the home. I will go to cement industry, and before I go to my conclusion. I think cement industry, because you know what is cement. Cement is using a chemical reaction, the calcination. Limestone is containing O2. So it means that CO2, when you are looking on the emissions of cement industry, they are coming not only by the fact that you need heat, but also by the chemical reaction itself. It means that it's not so easy to decarbonize cement industry. It's clear that you can try to use heat coming from low carbon electricity, but it's not a full solution. We need to explore alternative raw materials. It's already done in many countries, I'm sure in India too, to develop new cements, but changing cement means changing some rules, some practice, because cement is used everywhere for building, in many countries. And so it could be also interesting to make some coupling between cement and the plants from other industries. All that is described with precise examples in the chapter. So electrification of iron and steel industry is described with some precise case studies from what is done in different countries in the world, in Sweden, in Norway, in Korea, and in other countries. You have a few examples, I think, which are showing that we are in the way to do that. And I hope it could be useful to go through this chapter. I will end with the chapter on IT. We all know that IT is an increasing consumer, if I may say. We are all the consumers of for the ICT sector, and it's still increasing. It will be continue with ChatGPT, for example. We are using now supercomputing and so on and so on. So, but there are some ideas to maintain a reasonable increase of this consumption. And we give some examples and some ideas in the chapter. The conclusions, on some aspect, we were optimistic, or we are as scientists saying many technologies are existing now. Please, you have to deploy them. And we know that it's complicated. And we insist again on importance of education and training to help for the involvement of everybody in the world. And we think, perhaps we are not modest enough, that our academies in their countries and together could have perhaps more impact than they have now. So I thank you very much for listening. Here it's a very optimistic and musical view of the world, and I thank you very much for your invitation again, and to have this opportunity to present briefly our report. Thank you.
Thank you very much, Dr. Bamberger. This was absolutely marvelous. I think the fact that you have got real-life examples helps in making the case. And before I say anything further, let me request our colleague, fellow of the Indian National Academy of Engineering, Dr. Bibek Bandyopadhyay, to talk about the chapter on buildings. Dr. Bandyopadhyay is currently a distinguished professor at the JIS Institute of Technology, but he has been with the Ministry of New and Renewable Energy for a very long time, 30 years plus. But most importantly, he was the director of the Solar Energy Center, responsible for making it a vibrant international body, which is now the National Institute of Solar Energy, which co-hosts us. We are co-located with the National Institute of Solar Energy. Dr. Bandyopadhyay has been he's currently an editor, I think, of 3 journals. Including the Journal on Solar Energy. And without further ado, let me hand it over to Dr. Bandyopadhyay for the presentation on the building sector.
Thank you, Ajay, for this nice introduction. I thank everyone, ladies and gentlemen, for participating in this panel discussion. And I must thank our colleagues in INAE, Pradeep, Chaturvedi, Ajay, Mathur, and Indranil, Manna, for nominating me as a member of the working group that has given me the opportunity to working with Dr. Bamberger for the chapter on buildings. And there is another colleague of us, Professor Sudhanshu Chakraborty, who has contributed majorly for the chapter on the cement industry. And Dr. Bamberger, thank you. I remember the exciting days we have worked on this report, and thank you for your very nice presentation in a very limited time. It's a huge report, but you have given succinctly the recommendations of the Energy Committee. Now let me share my presentation. Thank you. What we have done in the building chapter, that we try to find out what is actually the energy consumption for the building sector. Interestingly, 36% of the total global energy used is being consumed by buildings. 6% for the construction and 30% for the operation of the buildings. That is around 1/3 of the global energy is being used by buildings. 22% by the residential buildings and 8% by other buildings, the commercial, institutional, industrial, etc. And the carbon dioxide emissions from these buildings constitute 37%. That means it's a huge carbon emitting sector. And when we call the operation of buildings, we know it is for lighting, for space cooling, for space heating, cooking, water heating, and innumerable of new appliances which have come and which consume electricity in the buildings. It has been found out that around 55% of the total electricity generated globally is being used by buildings, and rest is coming from coal, oil, and natural gas. Next slide, Professor Dai. Now, if we see this historical energy consumption graph, we can find that the two sectors whose energy consumption is increasing very fast is lighting and space cooling. Lighting we can understand. That is because the energy access in all the countries have improved very well by the Sustainable Development Goal taken by the United Nations. They have progressed very well, and people are using lighting, the very basic thing for survival. But one good thing has happened in the lighting sector, that energy efficient lighting has come in a very good way, and in most of the countries it has gone in a very commercial way. But space cooling, if we see, has been increasing tremendously. Not space heating to that extent. Certainly space heating is also increasing, but space cooling is increasing very fast. The reason is the emerging economies, their building construction activity is now very intense and going to continue for several years. The reasons behind are very well known: increasing population, more wealth, the aspiration for a higher standard of living, and urbanization. And most of these countries in the emerging economies are in the warm or tropical climate. The temperature of these countries require cooling, and therefore the energy consumption for space cooling is expected to increase in a very faster rate. So unless we take proper measures in the space cooling sector, the buildings, the technologies which are being used will keep this carbon emission locked for several years. And that's why it is time to see that how decarbonization aspects can be taken for the space cooling. We have to remember that cooling is a development requirement. Next slide. If we see in these developing countries, in the emerging economies, we find that there is, in the countries of South, a very large gap of space cooling, and that is to be catered in the coming years, maybe within 2 or 3 decades, when we have already taken the place of bringing down the carbon dioxide emission. Next slide. And innumerable opportunities are available today. Better access to electricity, advances in technology, their cost reduction, newer advanced materials, advanced design practices, and so on and so forth, which are very well known to the technologists sitting in this panel discussion. Next slide. So for decarbonization, we take these options, that is building construction, where the demand of virgin materials for building is to be considered, and energy efficient building design. We have to remember that the requirement of space cooling totally depends on the design of the building. If we can take advantage of the ambient energy, avoiding sun during summer and utilizing it during winter, that itself supplement a lot of energy for space cooling and space heating. And energy efficient building designs are now well adopted by many countries, including in our countries. Fortunately, I have the advantage of working in this sector for last 30 years, and we have seen it is possible to design buildings under the present condition in more energy efficient ways that would reduce the space cooling requirement and also space heating requirement. And energy efficiency would certainly bring down the energy consumption and therefore the carbon dioxide emission. But we have to remember that we have already a large pool of existing buildings, which probably have been designed not so energy efficient way. So there is a scope for retrofitting these buildings with improved building design, introducing local good technologies, the renewable energy technologies, and the changing equipment for low carbon emission. Next slide. So in this work, what we have done with many experts from different countries under different situations, the following messages and recommendations have emerged. A large panel of technologies is available today, allowing us to act immediately on the decarbonization of buildings. The principal avenue for buildings decarbonization has been identified as more and more electrification. Electricity is the desired energy that would help us giving lower carbon emission. And the situations are completely different in different countries, even in different regions of a particular country. So what we need actually is clear, stable, and holistic policies to effectively accelerate reduction in buildings emission, locally adapted design, construction and equipment, well-balanced existing retrofit solutions, and electrification for decarbonization. Because in electrification, what already we have seen that renewable electricity has come up with lower cost and lower carbon dioxide emission, rather negligible carbon dioxide emission. As more and more renewable and green electricity is integrated to the grid, we'll be able to utilize this electricity for doing all our works in the buildings. So more green electricity is required for the decarbonization, and which is very much possible under the present condition. Also, we have to take advantage of the digitalization, the control systems, and that would help us bringing down the energy consumption in those buildings. We have already started in our country, and many other countries, work has started on smart cities that would work on smart buildings, smart way of living, and that would bring down the electricity consumption and therefore the carbon consumption. Next slide, please. And very interestingly, if we see the requirement of cooling, which is an aspiring thing for these countries in the south, the emerging economies, there the availability of solar radiation and wind resources are quite good. And therefore, if we can properly harness this energy, integrate with the grid, with ever lowering cost of electricity and ever lowering cost of carbon content per unit of electricity, probably we'll be able to do it. I find it is quite a sustainable solution that can be provided to the building industry. So we are in conversation with International Solar Alliance, Dr. Ajay Mathur, who is the Director General. We want to bring these technologies to this international forum where we can take it up in various countries, because Dr. Mathur is heading an organization which has innumerable number of countries from these emerging economies. From the Indian National Academy of Engineering, which has vast pool of engineering expertise, we can hold hand and can help in propagating these technologies in a practical way. In energy technologies, in energy regulations and policies, in business models, and in market intervention. Thank you. Thank you for your patient hearing.
Thank you very much, Dr. Bandyopadhyay. This was very, very useful, and it's now speaking not as the moderator, but as a person who is associated with the International Solar Alliance. I look forward to seeing how we can work with INAE and CAETS in general to see how we can expand the reach of this report and implement its findings. Without further ado, I do understand that we are now almost at the end of our time, but Colonel Rai, I hope that we can take some time for discussion, because that's where the meat of the discussion of the seminar will occur. Can we have about 15 minutes for discussion?
Yes, sir, we have catered for that, sir. Yes, sir.
Okay, oh, thank you. Possibly I could start off, and I start off with the question. This is obviously a huge effort which has been put together and puts forward extremely valuable suggestions on how we can move ahead. Now, for example, let's look at heat pumps. Heat pumps make sense in air conditioners. And therefore, my question is, what does integrating air conditioners in heat pumps involve? Can the current companies do that? Would we need regulations in order to move ahead? Or can the market forces by themselves move this? Dr. Bamberger or Dr. Bandyopadhyay, anybody?
Yes, from the work what we have done.
Bibek, please.
Bamberger. Yes, please, you tell.
I think there are too many different cases. I think in some cases, reducing some some energy losses is not costly and brings money at the end and reduce the GHG emissions at the same time. That is not a general case, but it happens. It may happen in some plants, industrial plants, which are not really optimized. It may be also for some categories of buildings, but in other cases, it's clearly there need some incentives, or there needs some new regulation to push the industry. That's clear. And in some cases, it's also a matter of culture and on organization. So we have very, very different situations. I don't say that we were addressing all situations in the report, but I think through the examples and the case studies, you may see that in some cases, it could be very quickly have a return on investment to do something. And in other cases, it's clearly a push by the government. And I think in that case, in particular, allow me to insist on what the Japanese and Italian colleagues are doing on benchmarking between industries. I think it's especially interesting. And I think also that in some cases it's very complicated. For example, on cement, I didn't mention in cement, Sudhanshu Chakraborty was in this group, and your colleague, and we have seen that for cement, for big cement plants, it's very difficult, very complicated. So, but I'm sure that you have all ideas on this subject.
Thank you very much. Bibek, would you like to add something?
Yes, I fully agree with Dr. Bamberger that it is necessary for benchmarking. What is happening in these emerging economies, because there is money now and there is aspiration. People are purchasing air conditioning systems, but the whole market has been taken over by good-looking, low-cost air conditioning systems, which do not follow the complete energy efficiency measures. So therefore, government regulations are required to see that simply not lowering the cost, but also keeping the energy efficiency in mind, the air conditioning market is to be regulated.
Thank you very much. I see Sudhanshu raise a hand and Mr. Higde. So Sudhanshu and then Mr. Higde. Sudhanshu?
So you are muted. Don't hear you.
Mr. Higde, can we move ahead with you and then come back to Sudhanshu?
Yeah, thank you. It was an excellent presentation by both the speakers, I should say. We learned quite a lot. But coming back to this construction sector, that is in the built environment, what we see is the major contribution which is taking place is because of the concrete as well as the steel, which has been used as a building materials. And one of the problem is, in controlling the carbon dioxide emission to the environment because of the steel as well as the cement is, most of the carbon dioxide emission is taking place because of the embodied energy in the cement and the embodied energy in the steel. In fact, in the steel, 78% of the carbon dioxide emission is because of the embodied energy. And I say the electricity which has been produced for production of the steel itself, rather than the direct emission because of the carbon dioxide, because of the process of the manufacturing of the steel. Similarly, in case of the cement also, it's almost around 58%, according to my calculation. is because of the embodied energy. When I say embodied energy, the energy used, fossil energy used for the production of the cement. So the challenge is, how do we replace this energy with the renewable energy? But what I understand, talking to a lot of energy experts in the industry, that it is not possible for us, especially in India, to completely switch over to the renewable energy by 2070. In 2070, we have been committed to achieve the carbon neutrality. What I see is, only way, what I was told is, whatever is not possible to achieve for not going for the renewable energy, the balance has to be achieved by the circular economy, as well as the CCUS. Like basically the carbon capture, utilization, and the storage. So I see, in my opinion, controlling the carbon dioxide emission in the process itself. Presently, the Indian state of technology is direct carbon dioxide emission, which has been taking place, is around 0.8 ton carbon dioxide emission for the production of 1 ton of steel. That can be brought out according to the international state of the art technology, and also the targeted state of the art technology is around 0.1 for the cement. Like that is from 0.8 to 0.1, 0.03. I think we should try to bring it down to 0.3. And in case of the steel, presently our state of the art, state of the technology is 2.5 ton carbon dioxide emission it is emitting for production of the 1 ton steel. Internationally, it has been targeted to bring it down to 0.11 by 2050. I think we can bring it down to 0.3, perhaps. The most of the challenge is coming from the energy sector itself. Even for the construction industry, what I say is, how do we replace this, non-renewable energy to the energy, renewable energy source, that is the non-fossil energy. I think that is the most challenge. From the construction sector, I think we look forward to the energy sector to provide us basically the renewable energy for the production of the steel as well as the cement. The challenge is more as far as the construction sector is concerned there. That's what I feel.
Thank you. Can I ask Sudhanshu to comment, please, if he's there? Else I'll again request Dr. Bamberger and Dr. Bandyopadhyay to respond. Sudhanshu?
Yes, good evening. This would be related but not directly related to the presentation, Dr. Mathur. This is, I would ask the question to Yves, that I was shouting from the rooftop about the carbon capture, utilization and storage, which I think without that, we'll never be attain anything what is called net zero. And recently also we had a seminar in IIT Bombay. There we have seen that still the progress is extremely limited, in the sense that we heard the Norwegian presentation and we have discussed in CAETS Energy Committee meeting that what it is going on in the Heidelberg and others. Do you have any other additional information? And I mentioned to you that we should give a little bit more emphasis on the carbon capture and storage and utilization. It has come out, but it has not given any specific direction. So I should be very keen to know if anything is known to you, Yves. I shall be most grateful.
Professor Bamberger, can I request your comments and then I'll add my own experience in this area?
No, I mean, it's not a comment. Basically, I wanted to know from Professor Bamberger, what are we doing in terms of the storage? I mean, so whenever we talk of renewable, very rarely we immediately use. In many cases, we need quite a bit of storage, and that also accounts for certain energy consumption, either for producing the devices or for or for utilizing it when I need it, meaning the batteries and their production and their distribution and so on. So is that also a matter of concern? I mean, so that was my question, not a comment.
Okay, because
Yeah, Dr.
there are
Pradeep,
some
go ahead.
echo for me. I'm to ensure that I understood your question. Your question is on the energy storage, yes? Okay.
That's right.
I could say first, sorry, one technology is that we are on CO2 storage, we are on energy storage, and because there was another point on CO2 storage. I will come back to that briefly, Ajay. First, concerning energy storage, I think one type of technology that we probably didn't insist enough on in our report is underground heat storage, underground seasonal storage. I think it's in water, in underground, in the soil, in rocks, and so on. I think these are technologies which allow for seasonal storage. I don't say that it's useful in all climates, but for example, in European climate, and where you have really seasonal variations in temperature, or between day and night, I think underground storage could be very useful. Not to store all things, not to store all energy, but it could allow a big reduction. I give an example very briefly. If I remember, in China, in Wuhan, in the region of Wuhan, where they have a big variation between winter and summer, and they have much water, lakes and underground water, 2/3 of the cooling in the summer is done through water or underground storage, and 1/3 only to rooftop. I think probably in our report, I don't know, Bibek, your opinion, but I think globally at the world scale, I think we had to think more to underground storage. I'm not thinking to geothermal energy. I'm thinking to storage at 100 until 100 or 200, 300 meters. I think in many cases it could be useful. Concerning CCS and CCUS, it's mentioned in the report as ultimate solution if we don't have direct electrification or process change which allow to produce no CO2, but it was not the goal of our report to describe the application of CCS, technologies of CCS. But it doesn't mean that it's not important. It's mentioned in the report, and it was on my third slide, if I remember, as part of the solution. But I don't want to be too long. Sorry, Ajay, I was perhaps too long.
Thank you. No, that's absolutely fine. I think the key challenge that we have seen is that there has been no cost reductions in CCUS. We, in 2007, 8, 9, 10, we looked at CCUS as the panacea for the electricity system, that fossil fuels will produce electricity, and the carbon dioxide we stored through CCUS. But renewable costs fell fast. Then we said, okay, from the steel sector, we will see CCS coming up. But now with the SSAB doing the hybrid process, we see that iron making is moving towards hydrogen reduction as well, which may also limit CCUS, which means that at this point of time, the cement sector may possibly be one of the 3 or 4 sectors, possibly the only sector, but maybe 3 or 4 if you add petrochemicals and so on, where CCUS may be used. We need to ensure that prices of CCUS come down dramatically. And that's why U is important, because U enables the fact that there is some revenue stream which allows people to invest in this as well. But without further ado, can I request if there are any other comments? Sudhanshu, I see your hand, but Sudhanshu, can we do an offline discussion just in case there's anybody else who wants to say anything? Okay, Sudhanshu, can you come in?
Just I will be very brief, sir. This is about this cement carbon capture and storage. Again,
Sudhanshu, could you speak a bit louder, please?
about this carbon capture and storage in the cement industry, we got a lot of noise from some cement factory in Tamil Nadu, and it was told that soon we are going to implement it. And then when we inquired, as you know, that we tried to find it out more information, and this is more than 1 year, and everybody is hiding on that issue. I don't know. It might be the proprietary.
Anyway, so what you're addressing is an Indian policy issue. We don't even know what the policy issue is. So that I think we can. We will park it for the moment because this is a discussion on the CAETS report, which is a global report. If there are no other comments, can I then hand it over to Mr. Pradeep Chaturvedi, who is the convener of the Energy Engineering section of the Indian National Academy of Engineering. He has been a leader in the energy and environment area in this country. In fact, I think most of the policy in this area has started with him. He can well be called the father of energy environment thinking in this country. So without further ado, Mr. Chaturvedi.
Thank you very much, Dr. Mathur, for your wonderful conduct of this this discussion. When we had the first meeting of this energy committee, Yves asked me what could I do for the study. I said there are two things which I can do very well. The first is the starting point. I've prepared the outline of the report and prepare a template as to how the report is to be done. And the second part that I can do well is to write the recommendations. And I think that went well with Yves, and we had been able to do. But I must say this is one of the best reports. I have spent now more than about 40 years with the World Energy Council and the International Energy Agency. They're working on their reports. Let me tell you, this is in a number of selected areas and the in-depth studies that we have done and the number of discussions that we have organized. There is no other parallel energy report on technical matters which could have been done, which has been done over the last 40 years. And if one has to go through each of these chapters very deep, you'll find that everything, the total plan for implementation is available in every chapter. And this is why you have recommendations chapter-wise, whereas you have the recommendation also at the end of the report. So you can take the last recommendations for the policy matters, take the intermediate report on every chapter for implementation, and you can realize that how seriously it was taken by Yves, that when we thought of heat pumps and we wanted to have more detailed discussion as to what is to be done, we had Mr. Onni Krishnan specially invited, and he spent more than 2 hours, and we had experts from other places. But that set the matter right, that heat pumps can be an important source for the buildings and smart cities. Similarly, on the policy matter, we had someone who we have not recognized, Professor Ambuj Sagar from IIT Delhi. He spent a lot of time relating how the policy matters need to be understood. And even when we are talking of the new energy inclusion, how it has mattered in the past, but if we wish to implement this on a global scale, how the national governments, local governments, and the regional governments have to come in and really understand their policies and take positive policy measures. And now these are the kind of inputs we had from 69 other experts. But these have made the report more valuable, and this is applicable to, it has the regional context and the national context. I had the opportunity to speak about it on 7 or 8 different occasions, and every time I found that professionals, including the architects, the civil engineers, the consultants and all, they were very keen to go ahead further and work on this report and see how they can really implement. Now we need, if you're on the building sector, we need architects and consultants all the more to really come in and make understand and act with us. But similarly, other professional institutions, engineering institutions, also were very keen to have larger discussions, see how they could carry it to the people. So, if of the recommendations which the last which Yves had briefly mentioned, you see that it talks about we have certain technologies already available. We say that new technologies will have to be done and large investments are required. But it was observed that more than 50% of the work would still be done with the existing technologies. They are being properly utilized. So what you are talking about of the futuristic technologies, we don't have to wait for them. Let us improve on it and then see what we can do. And along with it, the energy efficiency matters must be put into order. Similarly, the second part, it is not necessary that to go for low GHG emissions, you have to change over everything from fossil fuels to renewables, then only you will have the lower GHG emissions. But they are different. These two, the fossil fuels and the renewables, both will grow and they'll take their own time, and there are different reasons. We have just seen that the government of India, with the Prime Minister, has announced that we'll do it net zero by 2070. One simple reason was that the financial investments which India has done in the fossil sector, that is the thermal power station, the power plants that are common have a life of almost about 35 years. With 15 years of retrofit, you get 50% of value available to them. And that is how many of the energy experts had emphasized on the Prime Minister that we must say that we'll do it by 2070, but we may attain much earlier. There are many IT industries who have said that they'll do it by 2030, some of them even by 2027. So these options India has gone through very carefully, and we have taken it. The next important recommendations of this, which was on education and training, especially on technology and science. But this is where it's not that only the government has to really come in, but it was thought that the academies, like the Indian National Academy of Engineering, would play a very important role in really persuading the governments, the academics, and other institutions to really take forward this message and move at a faster pace. I mean, any push from INAE or other academies around the world was thought that will be a much more catalytic than anyone else doing, and it is necessary because we have to carry the message to the citizens and create a public opinion also in terms of accepting these new technologies and bringing in the new low GHG emission technologies at a faster pace. And the last important recommendation that was made was that we have to bring in the leaders, the political community, and the governments everywhere. We don't have to work as the governments or as a replacement for them, but we should really provide that we are giving them the inputs and the means to take action. And there again, it was thought that if academies will come out and make strong recommendations, every government everywhere will really listen to it. And I'm sure INA has its own influence if our president would like to look into it, and the government of India would also listen to it. I mean, these are quite a few things which we have two major things that we have come out with. Everyone thought of those 69 experts who were involved with it. One was that we should carry the message through the academies and through all of the channels as wide as possible. And number two, create models of success based on these 7 chapters and the 7 areas. And even if we can create one model each, we would be carrying the message much faster, and it is on a much more sound footing, which can then be followed up. And this was the reason why we were trying to work out if Dr. Ajay Mathur would look into it with his friends in the International Solar Alliance, because these chapters, especially on the building sector, when you're talking of the cooling loads, which are about 55% of the total energy requirement, if we can go into Africa, go into Southeast Asia and other places where these loads are increasing, and see how we can do through lower GHG emission technologies. This will be very good, and I'm sure the Yves and also Professor Manna would really look into it seriously and to think how we can work together with ISA and then carry these, serve the whole humanity. I mean, that is, we have an opportunity to serve the whole humanity. And as they say now, they don't need sympathy, they need empathy. We have to put ourselves into their position and see how best we can serve them. We have to go in for the people-centric development. And I think here is an opportunity for us. And I'll request Yves, Professor Manna, Dr. Mathur, to kindly look into it. And Professor Dr. Mathur, I'll hand back to you. I've done my thanks to all of you, sir.
Thank you very much. With that, Professor Manna, if it is okay, when we close the seminar?
Yeah, of course, after recording our deepest appreciation to both Professor Bamberger and Dr. Bandyopadhyay.
Yeah.
Many thanks to both of you. Dr. Bamberger, we are delighted, and Dr. Bandyopadhyay, thank you very much. And we look forward to everybody coming together again on a platform when we hope we can move one step further. Thank you very much. Bye-bye.
Thank you.
Thanks for the invitation.
Bye.
The best.